Hi, welcome to the participants of the one-week training program on AI in agriculture organized by IASRI. I am happy to discuss about the use case of real-time monitoring of pink bollworm in cotton by deploying AI-based smart pheromone trap in this training program. I am Dr. K. Ramesh, Principal Scientist Entomology, positioned at Regional Station of Central Institute for Cotton Research at Coimbatore. So this development of AI-based smart trap was taken place at Coimbatore, and I am briefly discussing about these use case now. So the use case will be dealing about the issue of pink bollworm, a big issue of a countrywide impact and the difficulties we faced in monitoring and management of the pink bollworm in cotton and the development of AI smart trap for uh, easy monitoring of pink bollworm. And again, we will see about the deployment of AI trap in Punjab state in a pilot scale and outcome of the project and concluding remarks. This is the brief presentation timeline in the while discussing the use case. So the pink bollworm, as I told earlier, this is pest of national importance. It created almost havoc in last decade in cotton production, especially. Actually, this was a older pest of cotton in 1980s and 90s. This was the key pest, which created a big impact in the production and quality of cotton. But after the introduction of BT cotton in 2002, the bollworm effect and damage has came down drastically. Almost for a decade, the pink bollworm and other bollworms like American bollworm and spiny bollworm were not major issues. So till 2015, 14, 15, the issue continued. So almost for more than a decade, the cotton production was without the problem of pink bollworm. But after 2015-16, the pink bollworm started developing resistance to the BT cotton technology. So it impacted seriously the national production. The resistance started in the states like Gujarat and Maharashtra in the initial stage, later spread to South Zone uh, states. And in the recent times, almost from 2018-19, it spread to North Zone, states like Punjab, Haryana, and Rajasthan, and created a big impact. Actually, the pink bollworm is an internal feeder, so that gives big trouble for the farmer in timely monitoring and timely pesticide application. So this causes big problem for pest monitoring as well as timely application of pesticide. So the visual symptom of infestation will not be visible to farmer or whoever go for monitoring. So the during initial stage of flowering, the symptoms will be visible. Like you can see the rosetted flower here. And after that, the larva will go inside the bowl and it start feeding inside the cotton bowl. So the symptoms will not be visible to the naked eye. Either if you see during, if you want to monitor the damage, we have to cut open the bowl by destructive sampling. Then only we can observe the uh, pest occurrence. Or we can see the visible symptom in the final stage of the crop growth, that is during the harvest. So only during flowering stage, initial flowering stage and final harvest stage only we can able to see the visible symptoms. In the meantime, it is very difficult to monitor. So it is very difficult to judge the economic threshold level and farmers face very difficult in uh, taking the control measure. So that the you can see the production statistics almost. In 2013-14, the peak production was 398 lakh bales, but it got drastically reduced due to the single pest, and now it came down almost to 343 lakh bales, almost more than 50 lakh bales has been reduced due to the single pest, and the lint yield, that is cotton lint yield per hectare, has been reduced from 566 kg to 447 kg. That is more than 20%, exactly the 21% of yield reduction by the single key pest. So this is the challenge in management of cotton bollworm faced by the farmers as well as the scientists engaged in research and monitoring. So the newspaper cuttings, you can see very well the impact faced by farmers throughout the country, especially in North Zone. So this single pest made a big havoc. So farmers dumped the cotton crop. They shifted to paddy, maize, and other crops, and severe yield reduction. And, it gives a big trouble to cotton textile industry also. So in last few years. And from the data we collected, that is the pink bollworm infestation. As I told, initially it started in central zone during 2014-15, and in 2020 almost it reached all the locations across south and north zone. Of late, after 2019, it started impact in north zone also. Now you can say almost 47.75% location are recorded above the economic threshold level. And in central zone and south zone, over 10% of the locations are observed to be above ETL, which directly impacted the area and production. And in North Zone especially, in the last 2 3 years, it has drastically impacted the area production and productivity. So, uh, to monitor the pest, it is a greater challenge to take a timely pest management protocols. So, as I told, it is an internal feeder. So, there is an indirect method of monitoring through six pheromone traps. These are the conventional traps. It can be fitted in the field, and the adult stage of the pink bollworm can be monitored using the six pheromone trap. Actually, the insect has four life stages. That is egg stage, larval stage, pupal stage, and adult stage. Larval stage is the damage causing stage, and adult stage will be free. So by indirectly, the pest infestation can be monitored by the movement of adult moths in the field, and the pheromone traps have been traditionally employed to monitor the pest, especially in this case of pink bollworm. The pheromone moth trap catch is used to decide the economic threshold level to initiate the insecticide spray. In fact, the if the trap catch increases for consecutive 3 days by 8 moth per trap per day, we can assume that it has crossed the economic threshold level. So we can go ahead with the insecticide spray. But there are some limitations in using the conventional six pheromone traps. In fact, though it is simple and easy to use, it is laborious. Actually, we have to record the data at weekly intervals, and again, observation process in a wider area is laborious. Actually, it's a list of national importance, so countrywide monitoring is not possible, time consuming, and again, it prone to human error because there may be difficulties in identifying the insect. So it is in conventional system. These are the several limitations. Again, we cannot synchronize the multi-location trap data, and wider area monitoring is difficult for a pest like pink bollworm. So these are the limitations in observing data, observing and pest monitoring with the conventional pheromone traps. So to circumvent the limitation, the scientists at CECR, started working on smart pheromone traps using IoT protocols. So we developed initially the smart pheromone trap, which can transmit the trap images, and later we incorporated the machine learning algorithm to detect and count the pest. So this system is powered by a solar panel with rechargeable battery, so it can be deployed anywhere in the country. And the main condition is just the need a mobile signal, because the image will be transmitted to central server by mobile signal. So apart from this, this is a standalone system, weatherproof, and it can be deployed anywhere in the country, and it occupies very less space. In the corner of the field we can install it. The only condition is availability of mobile signal. So the AI trap record the insect catch as an image, and it transmits the data to our central server. Along with the image, we are getting the number of insect trapped also, and apart from that, it has a built-in weather monitoring system, temperature, relative humidity, and several parameters can be monitored, which can be uh, very helpful in deciding the or calculating the population dynamics of the pest. So this is the schematic diagram of the A smart trap. It has inbuilt camera, GSM transmitter, and the battery. And the pheromone septa, in fact, the pheromone septa will attract the insect as in the conventional trap. And sticky liner, the insect trapped in the sticky liner will be observed by the camera, recorded, and counted by the machine learning algorithm. So we have used YOLO machine learning algorithm for detection and counting of the insect. In fact, the our wireless smart trap technology has been certified by the ICR in 2023 as a ICR technology, and it has been appreciated by our various monitoring teams like QRT, RESC, and IRC. Members have appreciated the uh, CECR smart trap and its functionality. And the process is like that. The monitoring device will be in the field. So the pheromone compound gossip lure attract the pingolo moth. And the moths will be trapped in the sticky liner, and images are recorded periodically. We can configure based on our need, but we configured it to be hourly intervals. So at every hour, the trap will take the image of the trapped insects, and the data is saved locally in the memory card, and simultaneously it is being sent to the cloud. So along with the data, the weather parameters also, the concurrent parameters, that is the temperature, relative humidity, and atmospheric pressure data, simultaneous to the trap catch information, is synchronized and sent along with the image. So in the cloud, it is being saved, and we incorporated the ML algorithm in the cloud. So the uh, machine learning, YOLO machine learning algorithm hosted in the cloud app will process the image, will count the number of insects, and the counting result along with the weather data will be intimated to the client. Actually, the client having an Android mobile phone or having a PC or a laptop can access the information by various means. Just by through mobile browser also using a login password. You can just log into the trapping system, and we can know the real-time monitoring, real-time trap catch. And we have even developed an Android application for monitoring the data and giving real-time information to farmer. Anybody having these login credentials can see the information, either it be a farmer or extension functionary or a plant protection scientist or anybody or any policymaker or industrial person can monitor the real-time trap catch information just by clicking a mouse or just by tapping a button. So the advantage, you can see the web portal to access the data information. We have in the right side, you can see the Android app information. So it will give the insect count and temperature, humidity, atmospheric air pressure, and altitude, and again the time stamp of the image and trap cache information. So we have even developed a Windows application also. So this can be in offline monitoring and offline detection. This Windows app also can be used. So this is actually by investigating the real-time information with corresponding yield data, we can check the pest dynamics over a wider area. So we can monitor simultaneously over a wider area, and the pest dynamics can be comprehended in a better way. And with the availability of better data, we can establish a reliable pest forewarning system also for this, especially for the ping bollworm. And again, we can take precise and timely pest management practices to control the pest and to save the crop can be done in a timely manner. So again, after the trap catch information, we are giving the advisories to farmers also through various means, especially in the case of our pilot project in Punjab. So we collaborated with Punjab Agriculture University and the State Department of Agriculture in Punjab. So they will be having the login credentials. They will be going through the pest status, and based on the damage level and based on the crop stage, CACR has developed a crop window-based advisories. That is the flowering stage, that is 0 to 60 days. The uh, in a bold initiation stage, a bold development stage, and the bold maturation stage. So we have developed window-based advisories. So based on the crop window, the advisories will be delivered to the farmer through various means like mobile voice messages, as well, otherwise through mass media methods like radio or television, and social media through our WhatsApp as well as Telegram groups, and again by web portal of our CICR and Punjab Agriculture University. So the information, pest information as well as the crop window-based advisories are being continuously transmitted to the client. So, so initially we started testing the trap in all the three zones in Coimbatore, Nagpur, and Sirsa. And due to the demand by the Ministry of Agriculture, we started deploying in three districts of Punjab state, that is Mansa, Bathinda, and Muktar Sahib districts, at the rate of six uh, traps per district. We identified six villages in a district, and we have deployed these eight traps. And you can see the farmers. The traps are installed in advance. So before flowering started, we installed the traps. And to compare the efficacy of the eight traps, we have also installed the conventional pheromone traps at the rate of three per village. So the weekly trap catch can be observed both in a trap as well as in the uh, conventional trap. And again, we will be again the corresponding field damage also have weekly observations were taken to note the observations and to corroborate the trap catch information with the pest occurrence. So this is again another image showing the status of AI trap during the bold maturation stage. So all the farmers are these are the selected farmers, progressive farmers for deploying the AI traps in all the three districts of Punjab. And as I told, a web portal was developed for the accessing real-time information of the trap catch, and the login credentials were distributed to all the stakeholders for the data access. And apart from the hourly trap catch, additional reports, that is a daily count, weekly count, as well as ETL alerts and historical reports also can be accessed through this web portal. And the information not only can be viewed, but also it can be downloaded as Excel file for the period required. And again, provisions were also given in the home page to see the trap catch information as a graphical representation, so that it can have we can have a snapshot of information just by logging into the window. You can see that daily trap catch, weekly trap catch, weather data of all the locations, and whenever the location crosses ETL, so an ETL alert also will be shown by location wise. So we can issue alert message accordingly. So almost more than a lakh images were received from the all the 18 traps since June 2024. And the YOLO algorithm, it was very robust, and we could see the detection accuracy is more than 96%, and it very efficiently identified and counted the ping moths throughout the study period. And apart from observing the ping catch, daily alerts and weekly advisories were sent to the farmers. Daily alerts through WhatsApp as well as through social media channels were sent to the all the stakeholders, and weekly advisories also given to the all the stakeholders. So to directly reach the farmers, so we used voice message of 30 seconds duration, that is pushed through our GSM mobile network. So any farmer having a 2G mobile will be receiving the information. So we made sure that weekly messages are being sent to the. So the voice message of 30 seconds duration in the local vernacular language, that is in Punjabi language, pushed to the cotton growers, all the cotton growers in the state. So we have a database of over 28,000 cotton growers in the state with district level mapping. So whenever a particular district has crossed ETL, so we will be sending a specific alert to that district. Otherwise, we will be sending a normal weekly voice messages to all the farmers in the state. So, like that, we have sent weekly advisory messages through mobile, as well as ETL alert message to specific district farmers through this voice message, GSM voice message network. So, for over 3 lakh voice messages were sent to the farmers during the crop season. And apart from the voice message, we used social media and mass media channels also to deliver the information. And even we made personal phone calls to farmers, group messages, and announcement in village Gurudwara Sahibs on a regular basis were carried out to disseminate the information. And again, for each district, we have deployed on field staff. And the field staff will regularly visit the village to observe the pest infestation, to observe the trap catch in normal conventional pheromone trap, and he will interact with farmer, and he will make sure that the advisories are received, and the pest management uh, protocols are being taken care. So this is the images of Punjab state government officials monitoring the trap locations. So the key findings from the one year study that is conducted during the 2024-25 Kharif season in Punjab, we could able to get encouraging results. Actually, we could able to see the pink bollworm has 4 to 5 population weeks during the crop season, with a maximum trap catch of 447 moth per trap per week. So this is the mean value. And from 38th standard week, that is from September 3rd week, the trap catches were consistently high. But despite the high trap catches, the bold damages were kept below ETL, that is below 10% bold damage levels in majority fields due to the timely alert and timely pest management intervention by the farmer. So this is the success of deployment in spite of the highest population pink bollworm population levels. We could able to reduce the damage and keep the damage below economic threshold levels. And in some villages, we find some unique peaks. That is some unusual peaks compared to in the 18 villages. Only in 2 to 3 villages we found this unusual peak, and we started looking for the reasons, and we found actually the staking of cotton crop residue near the field is the key factor for increasing infestation. Actually, I told in the beginning, insect uh, pink bollworm has 4 life stages, that is egg, larval, pupal, and adult stage. Actually, during winters after harvest, the fourth instar larva is overwintering in the crop stubbles, and again in the pupa also it overwinters inside the crop residue. So during the next season, the residual population from the staked cotton uh, it attacks, and the infestation will be very high whenever the farmers take the previous season harvest near the field. So this phenomenon has been documented and recorded in the 2 villages, that is Gairibaki village in Batinda district and Balaike district in Mansa district. So we are giving advisories to farmers based on our observation. So staking of cotton crop residue near the field is in fact detrimental to the crop, and again it increases the infestation level. So this is another the key finding from our A trap pilot project, and we could see the this is the season wide trap catches across all the locations, and we compare the trap catch information from the conventional and funnel trap. Of course, the trap catch in the A trap is comparatively higher on almost all the locations because of the increased surface area and bigger trap size. So this is better than the conventional pheromone trap in recording the information. So this another finding we received, and we compared the AI trap farmers and conventional farmer with respect to the damage levels like flower infestation, green bolt damage, and open bolt damage. Because the AI trap farmers they have taken timely pest management measures, and whereas the conventional farmers they sprayed according to their own wish. So we found in AI trap farmers the infestation, flower infestation as well as bolt infestation were below 10% levels, while in the conventional farming, it was almost about 30% damage was observed. So due to the pest. So since the 8 farmers received timely ETL alerts, they could spray and they avert the damage in time. Not only that, they have even saved on insecticide cost because they 8 farmers they have sprayed an average of 6.2 insecticide sprays compared to 10.1 spray. These are the mean values in uh, conventional non-alert ETL based conventional farmers. So the farmers almost they could able to save 38.61% cost in pesticide usage. So the due to timely intervention, we could able to save the crop, we could able to save the cost of pesticide application also. So these are the dual benefit we received due to the timely pest intervention. So apart from that, we have demonstrated that the use of ICT and IoT tools for area-wide pest monitoring, and this is actually more cost-effective than traditional method of employing manual field survey. So we got a very good positive feedback from the cotton farmers. Mostly, they have appreciated the efforts wherein they could able to see what is the importance of real-time monitoring. And again, taking pest management at correct timely manner, so they could be able to save the crop. They could be able to get additional income. So this is the overall feedback received from the farmers. So they are very happy with the technology, and even we have recorded some detailed feedbacks from the farmers. Let us listen. This is just a 1 minute video of feedback from a cotton farmer. So this is another farmer giving feedback. So these are the feedbacks from happy farmers, and the outcomes of the 8 RAP project can be precisely told in 3 points. That is, due to timely intervention, the pin bollworm damage was kept below ETL in most villages despite the higher trap catches. And the process of early detection, timely alert, and timely pest management and focused collaboration with the different agencies would able to successfully demonstrate the pin bollworm management in Punjab. And the ICT and IoT tools can be very well better used as a monitoring device for pests of national importance like pin bollworm, and this is more cost effective also than the manual field service. So these are the brief outcomes of the ITRA project. And there are several reports, appreciating reports came in the national as well as regional media. So we can see that Down to Earth magazine, Hindu Business Line appreciated the efforts, and several agencies, including the Ministry of Agriculture, has appreciated the effort. And the Indian Council of Agriculture Research also promoted the AI Smart Trap. The trap has been displayed in the Indian Mobile Congress and the ICR stall on 5G technologies. And ICR has also highlighted this pilot scale project as a success story for the real-time field monitoring of cotton pink bollworm in Punjab. So this is in brief about the use case. And I hope you are benefited with the AI-based smartphone, AI-based smart pheromone trap. So thank you so much. Thank you very much for your patient hearing. Thank you.